We will now understand very basic of object-oriented programming. It is also known as OOP. If you do not have the understanding of object-oriented programming, but if you're still a programmer, if you understand the general coding procedure, when you look at the background code of any of the packages or sub-packages or functions within sklearn, when you look at the background code, it appears somewhat like this. For example, if you're looking at linear regression, this will be the backend code of linear regression. Class linear regression, DEF, underscore underscore initialization, then self. This word self appears multiple times, then some function, then this is what you will see. Actually, this is not that easy to understand. Even though you are good at programming, it's not that easy to understand and follow the actual background documentation of the code, the actual code that is written in these packages, because we are not well versed with this style of coding. For example, if we have to repeat the same task multiple times, we tend to create a function, and whatever we want to take it as input, we will take all of them as parameters. With multiple parameters, we create a function. We can call that function, we can call the relevant parameters, and we can get our output. That's what we tend to do. If you are repeating, if you're doing these kind of tasks, we generally tend to create a function. That is known as procedural programming. The programming that we generally use, that is procedural programming. For example, if we are writing a function for performing regression tasks, then we create a very large regression function. Within that, there will be sub functions. Function one will be calculating beta coefficient. There will be a function that we will write to calculate R square. There will be a function that we will write to calculate VIF. There will be a function that will be write to calculate adjusted R square. Like that, for a large particular program inside a large function, we tend to write several sub functions. Or if you are trying to analyze sales, then you define a function sales analysis, and you rate take all the parameters, and then monthly sales, weekly sales, or the daily sales, sales charts, or sales comparison, cumulative sales. You tend to create multiple functions inside a very large function. Now that is procedural programming. Usually we are very comfortable with this style of procedural programming until now. But object-oriented programming, OOP, is a totally different programming paradigm altogether. You write the programming or you write this code very, very differently. Instead of writing one function, we create multiple classes or multiple functions. Here, there is a new concept called class. It looks like a function. It's not exactly function. Basically, class is the different element altogether. We have to understand what is a class. So basically in OOP, what we do is we create classes, and we can structure large programs, huge programs in a much, much better way. There is a lot of lines of code that can be reduced if you are using classes. It's very, very easy to organize. First of all, it is easy to read. Yes, it is hard to learn. Once you master it, it is very, very easy to read, and the readability of the programming improves very, very much. Okay. And if someone else also creates object-oriented programming, it will be easy for us to understand no matter who writes that code. It very much improves software reusability. That means if you write one code, one class, it can be used at multiple places. Reusability is much, much better. In fact, if you are thinking about serious software development, if you are a serious developer, then it makes it much, much easier if you are using OOP concepts, object oriented programming. In object oriented programming, there are two major new concepts that are introduced: class and object. Very often you hear this class and object. What is a class? What is an object? Class is like a blueprint or a design. In a class, we have multiple methods, multiple attributes, etc. Basically, it is like a design. For example, if you take this example, x equal to 30. So x, which class is x? X is of the type integer. My message is some kind of message. Which class is this? String. So integer and string are classes. Okay. And then what is an object? An instance of the class is called an object. Here, what is an object? My X is an object. That is an instance. X is an integer. Y can also be integer. Z can also be integer. X, Y, Z are objects. Here, my MSG message is an object. An instance of the class is known as object. If you have a class called a person, then what will be an object? Alice. Alice is an object. Alice is a person. It is an instance. Let's say if you have a class called dog, and what is an object? The dog's name, puppy. Maybe that is the object name. That is an object. If you have a class called car, if your class is car, that is a blueprint. Tell me an object. Think of an object. What is an object? Ford or Toyota car. Student is an object. Then Jane. Like that, you have object, you have classes, person, dog, car, student, employee. These are classes which are like blueprints. And the objects, one instance is Alice, one instance is Buddy, one instance is Toyota, one instance is Bob. Basically, here it represents a person with some properties like name and age. It represents a dog with some properties like name, breed, age, etc. It represents a car, properties like make, model, year, etc. So here in this example, the person, dog, car, student, employee, these are all the classes. And what are the objects? Alice, Buddy, Toyota, Jane, these are all the ones that are actually objects. Let us learn a bit more of it. Let us see some examples to get a better understanding of it. Once again, how does that work? If you have x equal to 30, in fact, you can see it. Let's say, let me give a title here. Object-oriented programming. Oop, that is the one. Okay. Now, here, let's say if I write x equal to 30, in that print type of x. What type is that? Obviously, x, the class, the output will be, it is of the class integer. That means integer has some properties. Integer is a class that is defined earlier inside Python itself inbuilt. Let's say I have MSG, which is a message, and I'm storing it in here. Okay, my message. If that is the thing, if that is the string, then I would like to print what type is message object. What type is message object? It is of the type string. It is of the type class. So here the class is string. Here the class is integer. What is the object name? Object name is X. Object name is message, MSG. So for example, how does object-oriented programming work? For example, if we are writing a function performing regression tasks, if you already know about regression, well and good. Otherwise, just understand that it is one of the machine learning algorithm where it accepts some of the data sets X and Y, and it will give you the predicted value of Y. It is used for predicting the value of Y. So if you want to build a particular function for regression, what you can do is you can define a class called regression. Its properties will be input data name, data size, other details will be properties. The methods, which are called as functions. So every class has properties and methods. Properties are like properties of that class. That class, how it will give you, like, you can write the class name dot property. So methods are, there will be a function for methods are like functions. There will be properties are like real properties or some of the values, okay, related to that class. Methods are the functions. These are kind of factual values. These are the functions that we create. Method 1, calculation of the beta coefficients. Function 2, calculation of R square. Function 3, calculation of VIF. These are the methods. These are the properties. Let us see an example to understand it much better. So how do you define a class and object? You have to use this. You often tend to see something called self here. So what does this self? It refers to the object itself. Sometimes when you are defining a function, you have to pass on that class itself as an input. You have to pass on that class Sometimes you have to pass on that class and some other values as well, but every time you have to pass on that class. That is what the class itself is represented as self. So when you're creating some of the methods here, these functions are called as methods. This is a method. When you're defining these methods, you may have to give this class itself as the input. Okay, so that is why you have to use self in some places. Init stands for initialization. It is a very special method. It initializes the attributes of the class. So what are the attributes of the class? Some of the properties that we need to start the class when you're starting this class, or when you are getting started, or some of these values need to be initialized. It's almost like giving some initialization or setting the initialization of the values, which are the attributes of the class or the properties of the class. Let us define one class that may give us a better idea. For example, if you are defining a class, the class name is any point, any random point, two-dimensional point. So I am defining a class which is a point in a plane, two-dimensional plane specifically. Okay. So how am I defining it? I'm saying I'm defining def. First method I'm defining initialization. Now this comes automatically. You have to give it like this. You have to give two underscores init two underscores. This is the standard code that we have to write. This basically, this is the Python standard. It is indicating that this is a method that is very special, which is a initialization, and it has to be always self. You have to give the class itself as input, and you say x coordinate comma y coordinate. I have two properties, x coordinate, y coordinate. Now self dot x is equal to x coordinate, self dot x is equal to x coordinate, and then self dot y is equal to y coordinate. Okay, x coordinate and y coordinate. Now if you want to print something, you can print it, otherwise there is no need to print. Always print this point is equal to whatever you want to print. Let's say then self dot x. So whatever is the x coordinate, that will be printed, comma self dot y, that will be printed. Self dot x, self dot y, x coordinate, y coordinate will be printed, and then the closing parenthesis. Okay, that's it. Self dot x, comma self dot y, and then the closing parenthesis. Now that is the class that I have defined, any point. Now let me define an object. Point one is an object. So I would say point one is any point 0, 0. Now point one will be an object. So this is the point. Okay, let me just put this way. This point is this one. Okay. Now it has two properties. It has two attributes. What is it? Point one dot x. What is x? 0, 0. Let me put 1, 3. So what will be the output? Point one dot x is this one. Point one dot y is this one. It has two properties, point x and point. Let me create another object. How do you create another object? Point two equal to minus 1, 3. So you would say point two dot x. Point two dot x is minus 1. Point two dot y is 3. That's how you can create a class. This is a very simple class. You have to write define or create initialization. You have to pass the class as it is, and the properties, whatever properties that are required, that you will give. Now I'll expand it. So now what I'm going to do is I'm going to define a method now. So the previous one, these are all properties. Now I'll define a method that can be used somewhere. I'm defining a method called Euclidean distance. Okay, or simple words, distance, you can say that. This accepts self as input. Already I have self, which is this point. And if you're calculating the distance, you have to give new point. New point. Okay. So you have to give this point, which is anyway taken from self, and you will get it from the new point, and you calculate the distance. The distance is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is a Euclidean distance. First of all, I'll put square root. Square root means to the power 0.5. And now let me put x2 minus x1 whole square. So new point is also a point. So new point dot x, that is x2 minus self dot x, self dot x, new point dot x, x2 minus x1 whole square, whole square. How do you take the square? Star star 2 plus y2 minus y1 whole square. That means new point dot y plus minus self dot y whole square. So what do you want to return now? Return simply the distance. Return the distance. After return, you can give space and mention whatever you want to return, or you can give it as it is. Now this class is slightly different. Now any point, it has properties and it has a method also. You can use that method. Now let me define my point 1 again. Let me define my point 2 again. You have point 1 and point 2. So the first point is 1, 3. The second point is minus 1, comma 3. Now you can use this method point 1 dot, there is one more method called Euclidean distance, EU distance. And what does it accept? It accepts self, which is like point is anyway given. And what does it accept? It accepts another class of another point, point 2. You just need to mention point 2. So as soon as you give point 2, this new point will be considered as point 2. From that, it will take x value and y value, calculate the Euclidean distance. So here is the Euclidean distance 2.0. Let's say if this is 0, 0, and if this is 2, 2 point, 2 comma 2 point, then let us see the distance between these 2 points. 0, 0 to 2, 2, square root of whatever is, 2.8 to square root of 5 or something, square root of 3 or something like that. Yeah. This is the Euclidean distance, the based on this formula. There is one more distance called Manhattan distance, slightly different formula. What is Manhattan distance? Instead of taking square root of x2 minus x1 whole square plus y2 minus y1 whole square, it is simply absolute value of the differences. Absolute value of x2 minus x1 ABS, absolute value of x2 minus x1 plus absolute value of y2 minus y1. There is nothing like square root and all that. It's a different formula altogether. That's it. This is, let's say, different distance, distance 1, return distance 1. Instead of EU distance, it has to be Manhattan distance. Manhattan distance. So it has two objects now, or two methods. This object, any point is the class, and it has two methods, two properties, x coordinate, y coordinate. It has properties or attributes, and it has two methods, Euclidean distance or Manhattan distance. You can define point 1, you can define point 2. Let's say from point 2, you want to find out Manhattan distance to point 1, then you say Manhattan distance, and it accepts another point. Let me say it is point 1. Give point 1, then this is the Manhattan distance is 4. That is how you can use the class and the method in the class. The reason why defining a class, defining the method is very important is later on, if you are writing a very, very lengthy code, if there is a lot of software programming involved, it has to be well read, it has to be well arranged. So all the functions that are related to this class, this method will be inside this. And the beautiful point is, you can actually, if there is another class that you are defining, right now you have defined a class, any point. If you are defining a class called midpoint, then if there are some properties that are matching, if there are some attributes that are matching, then you can inherit from here. Inheritance is that ability to derive or inherit the properties of a new class from the existing class. For example, I want to create a new class called midpoint. I want to create midpoint. What is a midpoint? A midpoint is a point between this point and the new point that I have given, the middle point between 2 points. So if I want to define that class, I don't really need to start from the beginning. I can take the inheritance from here. So how do you define midpoint? Midpoint also has two attributes. What is it? So as usual, you have to say all this. A midpoint also, if you want to define, you simply define all this. So initialization, x coordinate will be there, y coordinate will be there, self x coordinate. This is that point. Okay, midpoint. Here I want to define a new method called midpoint. Okay. So what I'll do is I'll simply say mid underscore point. This is the new method. What does it do? It will take self as it is this point, comma, new point. It will take another new point. Okay. And what is the formula? Midpoint of what is the formula for midpoint? X1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay. Midpoint of x equal to self dot x, isn't it? Self dot x, this point, self dot x plus new point dot x divided by 2. Yes. And y coordinate of the midpoint would be mid of y would be self dot y midpoint dot y dot y dot y. Okay. Divide by 2. And what do you want to return? Yes, I would like to return. What do you want to return? I would like to return mid of x. Yes, comma, a tuple with mid of y. That will be the midpoint that will be returning. Okay. Now that is usually how you have to write if you're defining a new class midpoint altogether. But this and all is nothing but a point which is already available. It is already available. So when you're defining midpoint, again, you have to have the properties of like some of the properties, like for any point, x coordinate, y coordinate are common. Even when you're calculating midpoint, you have to have x coordinate, y coordinate. Why can't I inherit these? Like midpoint is any point only. So why can't I inherit everything from there? So what you can do is when you're defining it, you can define it differently. Midpoint in the parenthesis, you write inherit all the properties from any point. That means you take everything from any point. So midpoint means already everything from any point will be taken. That means within midpoint class, you will have x coordinate, y coordinate. Within midpoint, you have EU distance and Manhattan distance. Everything is inherited with this one command. Only thing that are new, which are not available in any point. Obviously, midpoint is not available in any point. You just write this. This is sufficient. You just write this. This is inheritance. Imagine you have defined 30 methods here. Again, defining those 30 methods will be totally mad. But if you have inheritance, you simply inherit everything from any point. Now, midpoint, you see here, it will have 3 methods. Midpoint will have the method of EU distance. So let me define that. Okay. So let me define an object of midpoint first of all. So let's say M point M is, let's say, midpoint. Let me call this as midpoint 1. Okay. So let's say the class name is midpoint 1, midpoint 1, 0, 0. Okay. This is point M. Now what you will observe is this point is M dot. You have X value, M dot Y value, though we have not defined it. But still they are there because they are inherited from any point. M has also EU distance. You can use EU distance. M has also Manhattan distance. M has also had Manhattan distance. Apart from those two, you have now M has midpoint. You have inherited midpoint. M dot midpoint. Define a new point. Let's say M is 1 point, N is another point, which is again midpoint one class, and it is like 4 comma 4. That is a different point. Now you write M dot midpoint. I want to find the midpoint between M comma N. Like M is anyway given here, self is given, so N, that should be fine. Here is the midpoint. 6.5 comma 2.0 is the midpoint between 9.0 comma 4 comma 4. In fact, you can use the other ones as well. You can also say M dot midpoint M dot EU. Though M is midpoint 1, since it has inheritance, you can write M dot Euclidean distance EU dist N. That is also fine. Inheritance. You can also write M dot Manhattan distance. So that is the beauty of inheritance. That's the reason why lots and lots of people, when they are working on large software development programs, they will be adopting object-oriented programming because it is easier to maintain the code. It is easier to read the code. If you have absolutely no idea, then this code looks very difficult to follow. But if you have good idea, then we can save lots and lots and lots of lines of code, and it will be much more reader friendly. A lot of the packages that are written in this object oriented manner. This is a huge field. This I have just given you a very basic surface level overview, but it is much more complex than it appears. But I have just given you an overview so that you can understand at least the basics of OOP. If you're interested, it's a very good field to learn. Maybe spend a month on object oriented programming. I'm sure you will actually master these whole development projects later on. Thank you very much.